it is normally through some structure. English has a structure, Swahili has a structure, mother tongue has a structure. So every language, when you're communicating, it has a structure, yeah? So is there a way that we can build a model that to some extent understands those structure, semantics, language semantics, and translate that in a way that can be, I can see Chris has raised his hand. Chris, please go ahead. Are you stuck? Chris?
No, I'm not stuck. I was raising my hand to say that I have raised my hand. Sorry.
Oh, okay, all right, no problem. So we'll proceed, huh? All right. Okay, so like I was saying, is there a way that we can build a model using algorithms that have been available that could understand some language as based on anchor on the natural language that we use every day, and most probably it goes around text analysis or even speech. Yeah, there are several areas: sentiment analysis when you're building a chatbot, when you're doing translation. Some of these tools we've experienced them in some of these platforms that we visit: Google Translation, chatbot. You've heard about Siri. Sentiment analysis is something that we hope maybe through this class we'll be able to actually build one. We'll be able to build one and get to know how to work with a sentiment analysis solution. Yeah. So just a minute. I'm getting a bit of distractions. Just give me a minute. Let me just sort out something here. I'll be right back. Okay, sorry for that. So I was saying in NLP, we have two key fields, natural language understanding and generation. So understanding is where we want to start and get a trainer machine to understand the natural rules, the rules that are governing the construction of any sentence. So it could be the semantics of that language, how it's constructed, and how you're supposed to use it. Now that is natural language understanding. Natural language generation, you're using algorithms to actually create tasks or even predict the next word. When you're using Gmail, you probably come across this. So the model is the one that is generating the next text or the next word, or you can generate it even, you can generate a complete sentence or even summarize a document. Yeah, so you've understood what it's saying and you can now summarize it from maybe even 50 pages to 1 page. You can do that with a machine learning. That is one field of NLP. So natural language understanding is not as complex as natural language generation. There are quite a number of concerns when you're trying to understand text, and one of them is ambiguity. Depending on which word appears at what point and the availability of a word in different sentences, there is a possibility of creating ambiguity in text. And for example, she is looking for a match and the fisherman went to the bank. So when you say something like the fisherman went to the bank, is it the bank where you withdraw and deposit money, or is it the bank where you start fishing? So is there a way of identifying this ambiguity using techniques available when you're doing natural language processing? So that is a scope within which we need to look at when you're working with NLP. Another one is syntactic ambiguity. The chicken is ready to eat. So this one, what exactly do you mean? Is the chicken the one that is ready to eat the food that you throw at it, or even maybe it's some grains? Or have you prepared chicken for you to start eating? So those are some of the ambiguity. And the last one, I think, is the referential ambiguity. The boy told his father the theft. He was very upset. Now you're referencing to the father or the boy, yeah? And to be able to do this, there's something called parts of speech tagger. Now in English, English is constructed in a certain format. So there are several parts of speech. POS is just as direct. We have verbs, we have prepositions, we have nouns, we have adjective, depending on pronouns, nouns, depending on now what the verbatim that you want to process. So the understanding of such parts of speech is very, very important to when you're doing NLP. And what I'm showing you right now is some of the parts of speech, and it's quite a long list. And we might need to revisit our English classes. I remember when I was in English, I never took it very serious. What is a verb? What is a noun? What is a pronoun? Adjective? Yeah, some of these things you never knew. It's just constructing. Who knew that I will be doing machine learning now and I need to be very proficient in some of these things? NLP. Yeah. So an example of a sentence is the dog killed the bat. So bat is a noun. There is a determinant. Kill is a verb. Dog is a noun. There is another determinant. Yeah. So each of those words is being tagged as part of the speech. Now the noun, the verb, the determinant, those are what we call the parts of the speech. So we have a speech and it has its parts. Yeah. So up to there we're good. Now this is just an explanation of how you identify parts of speech and in identifying some ambiguity, in this case syntactic ambiguity. Um, the flies like an arrow. Time flies like an arrow. It's the same sentence, but the part of speech it can mean differently. It can mean different things. So the understanding of these parts of speech is significant when you're interpreting or understanding what the text is about. When you're talking about text analysis, maybe you want to work with sentiment analysis. You need to know the parts of speech and the algorithm or the model you're building needs to find a way of understanding that. So natural language understanding heavily relies on the capability of capturing the ambiguity as well as at least getting to know and understand the POS, parts of speech tagging. Before the class started, I was having a discussion with Eric and with regards to our learning paths. And the beauty of the new strategy is you start something with very, very basic problem solving techniques. Like you could start building a chatbot by just building classifiers, something that we've done in class. You just build an algorithm that classifies text. And then based on the classification, you expose those classifiers in a workflow and you generate an outcome. And that outcome be sent to whoever is asking that question as an answer. So that is one way. You start with basic classifiers, and then you advance to more deeper techniques using the same example. So if your learning path is NLP and you want to build a generative chatbot, a generative chatbot is one that you've embedded natural language generation. Yeah. So the chatbot is capable of writing sentences by itself, like without being directed. So it's a bit complex, and much stronger, deep techniques are used to do that to build that kind of model. Yeah. But the most simple one is, say, even building a rule-based method. and then you go to retrieval methods, and from that you venture now into deep learning methods. So what you're seeing is some of the techniques that are used in tagging text and approaching a problem with parts of speech tagging techniques. Yeah. And this is approaching, that is basically what I had mentioned previously. So you have parts of speech tagging, supervised and unsupervised. So unsupervised, you have rule-based and stochastic method, and then you venture into neural networks. Neural networks where you either use LSTMs, yeah, or sec-to-sec. Those are techniques that if you start with classifiers, don't worry about the big terms I'm mentioning. Key point is, where is the starting point? So the new learning path is you start with something that is more simpler, and then move with the same learning path. Say it is NLP, you move all the way to deep learning. Yeah. So the same thing to, I had given a project like time series. You can come up with the time series problem. You're solving it using the normal standard time series algorithm like ARIMA. And then you use even deep learning techniques via LSTMs to solve your time series. So it's just, where do I start from? Solving the same problem, but learning as many algorithms as possible. It is possible, and that is the approach that we are adopting moving forward as our learning strategy. Okay. Now I've mentioned natural language generation. You can create and generate text. You can generate sentence. Yeah, and some of the techniques for generation, like I had mentioned earlier, we have LSTM, we have recurrent neural networks, and there's one called Markov chain. Some of these things will become much clearer as we do them practically. It depends on how, once again, some of these things, it's easier to show interest, but showing interest is not enough. You have to be committed, and you have to actually do something about it. And attending such sessions and deliberating and coming up with projects is just one of the things that you need to do. So it depends on at what point of the journey you will drop off. If you drop off sooner, you might not experience with us this journey where you see LSTMs. But if you're patient enough, you'll actually see how we implement a neural network to generate the same thing. Yeah. So don't worry about this. It is just worth mentioning, and it is my belief that in due course we will come to experience this either in these sessions or in your own path. So maybe if you choose your own path outside there, you'll come across some of these techniques, right? Now, the first thing when you're handling or processing text, building a chatbot, for instance, you need to split that word that you want to process into tokens. Yeah, so basically, tokenization, if you look at that, the blue part, tokenization is the first step in NLP. So each word is split to exist on its own. We call that tokens. And then we have bigrams. Now, those words, as it stands, we have each token as one. Now, when you group this into two, for example, tokenization is becomes one, is there becomes the second one, and then there first becomes the third one, and then first step becomes the fourth one, and then step in becomes the fifth one, and then in NLP becomes the sixth. So you will have 6 groups. And in that case, since you've grouped them 2 words each, that one becomes a bigram. Yeah, so that is what you mean by either bigram. So when those words are 3, they are trigrams. And when they are like now 4 gram, now Ngram is now a representation of that kind of grouping. Yeah, so you can choose to group them in either 2 or 3. And the reason for doing that is to further extract more understanding on what the intent is from the sentence, and also to identify possibilities of ambiguity within the text. So these are some of the techniques. Bigrams, diagrams. So it would be difficult for someone to solve a problem, especially an NLP problem, text processing, without using this Ngrams. And in notebooks, I will show you how this works. And then there is something called stemming. Stemming is when you're reducing the word to its root form. So there are some words that, like now, what is being reflected. If you take a word like affects, and then it has several possible formation. It can be affects, affections, affected, affection, affecting. So when someone says affecting, it means like that noise is affecting my studies, or that person is affectionate. He was affected by whatever it is. He was affections is too much. So depending on which word appears in your statement, it could mean something different. So reducing and deriving the meaning, it's good to get the root word of whatever word you're processing. So in this case, the root word here is affect. All of this word, it's affect. So that is another technique. Lemmatization is more or less similar to stemming, but in this case, lemmatization makes sure that it's a proper word. So if you look at, there are certain instances where you pick certain words. Like now, let me use just what we are seeing in the screen: going, go, gone, going, and go. This can go to go. If you use as stemming, it could mean gone with G-O-N and not without the E. So depending on the difference between stemming and lemmatization makes sure that it's a proper word, a word that actually exists, and more often than not, it's in the dictionary. But stemming, you could still reduce it to its root, but a keen look at the word, it might not exist in the dictionary, but it actually reflects the intent of that statement. So that is the difference. We have words like stopwords. Stopwords are basically words that are added to a sentence just to complete it, but it doesn't do anything to change either the meaning or the verbatim. These include words like there, full stop, some apostrophe. Those are words that we would consider stopwords, and the machine really doesn't need to have them in the sentence. So as you will be seeing later, these are words that we need to remove from the sentence, or when you're processing them. We have named entity recognition. Named entity recognition is from within the text. Can you derive certain objects that actually exist? It could be the name of a person. It could be the organization. I know the most common one all of us have experienced is the message we normally receive from M-Pesa. It normally has a date, time. It normally has the amount. It normally has the name of the person you sent the money to or you received the money from, and a couple of entities, what I would call entities. So if you were to process or even write an automation script, you need to figure out a way of, once you understand, okay, now this SMS message is about money sent to either a customer, you need a way of extracting this meaning or even these objects from that text. So there are techniques that help us identify these entities, and we are able to extract them and actually put them in a variable. Yeah, so that is called named entity recognition. Yeah, so it is important in a certain text or verbatim, you're able to, using specific techniques, you're able to remove or rather extract important information like the name of an individual from that text to be able to use it elsewhere. All right, so for example, this statement: Google CEO Sundar Pichai introduced the new Pixel at Minnesota recent event. So we have the name of the person, you have the name of the organization, you have the location. So if you're doing analysis of text, that conversation, and you want to see which words appear so often in terms of location, or which name, who is mentioned so often in a paragraph, then some of this would help in analysis. Yeah, and by extracting this, you can actually visualize some very interesting. You can come up with very interesting visualization. Now, chunking is basically identifying groups of parts of speech tag that, when put together, have a certain what is it called? A meaning. So you chunk the words into certain groups as guided by the parts of speech tagging, right? NLP, the first thing you need to do is techniques within which you can do your cleaning. You can do your data cleaning because there's a lot of things that needs to be done. There are things that you might not need depending on the analysis that you're doing. For example, if you're scrapping a website, you might end up having some HTML tags in your text that you don't need. You need to figure out a way of removing them. Things like full stop. Do you need to make your text, all of them, lowercase? Then you process. We've already seen some of the things we need to do. We need to tokenize. We need to remove stop words. Do we need to stem them to the root form, lemma them? Yeah, so there are techniques enabling us to prepare our data for machine learning just before we start. And then it is also important to visualize. A very common one in NLP is word cloud. There's a way you can build a cloud of all the text appearing in a paragraph or even a book. And then the good thing with the word cloud is the more bigger the word, the more often it is mentioned. So if you're analyzing a conversation between a customer and a company, and you want to know what are most customers complaining or talking about. So coming up with a word cloud will tell you, okay, most customers are talking about, say, real estate. This one is for property, real estate. And we also have conversation around brokerage, conversation around investment. So depending on the number of conversation in a text or a sentence, depending on the number of text, then it is much pronounced. It is bigger. So we need to generate a word cloud when you're doing NLP. All right. We also have to check on word frequency, things like word count per document. A document is just like a sentence where you're analyzing. A sentence could come from an individual customer. So you extract that sentence and look at what are the frequency of presence of specific words, unique words, and building a frequency plot for these words would also give you insights on your analysis. Very, very important when you're doing NLP. There's something called bag of words. So basically, a bag of words, it's actually a sparse matrix. What I mean by a sparse matrix is it looks at, you see, we split the sentence into tokens, and then after splitting the sentence into tokens, we create a matrix and check out in all this. Once, of course, we've removed the stop words, we are left with words that are of use to the machine learning algorithm. So we build a sparse matrix. A sparse matrix is basically, I would call it a table in which the columns form the specific words, and then the rows form again the indexes. So for the documents, so let's say document 1 has a specific word like now property. Document 2 does not have property. So when it has, it's a 1. When it doesn't have, it's a 0. So that is what we mean by a sparse matrix. And the objective is normally to reduce the sparsicity. You want to reduce that the presence of zeros. So if your sparse matrix has a lot of zeros, the objective is to reduce them, to reduce the number of zeros and have them refined. And there are techniques of doing that, okay? All right, now from the data set, basically, this is now excerpts of the code that I'm showing you. And then from the data set, you need to basically identify what is that target variable. So when you're doing sentiment analysis, you might be having a sentence on one column, and then you'll have a target variable, which is either this sentence is happy. So your column of the target variable y is a column that says whether the customer is happy or sad. So your target variable is binary. It's either happy or sad. If it is neutral, if you add neutral, then it could be happy, neutral, or sad. So your target variable is either happy, neutral, or sad. And the sentence now become your independent variable. So in NLP, you also need to define and extract your target variable. Now that is a code. You will see it in Jupyter, but that is a code that actually helps us extract that. Yeah. And then modeling, just like what we did in classification, where you split your y and x. Of course, after doing the preparation, like now using the techniques that are available when you're building the sparse matrix. So after doing that, you expose it and split it into x train, y train, x test, y test. Build your classifier the normal way, and build your confusion matrix the way we know. For those guys who've not done confusion matrix, we are going to use new strategy of learning. So you'll definitely come to learn all these things based on the project that you've picked. Yeah, and it will be very, very similar to some extent. And I personally, I long for the day that we will move and shift from basic classifiers to neural networks and to deep learning, and see and appreciate some of these difficulties. Because one advantage of using this path is you will definitely solve a problem using normal classification techniques. And then you will advance into a bit more advanced techniques where you are tuning hyperparameters and making changes and using deep learning techniques. And then you'll now start appreciating the importance of the advanced techniques like deep learning as compared to normal standard classification techniques. This will be much, much clearer to you as compared to if you started from deep learning. You see, if you just started from deep learning, of course you'll be good and in-depth, and you wouldn't appreciate the benefits of using the deep learning technique in solving a problem as compared to someone who actually solved the same problem using standard algorithms. That other person would actually own it and be passionate about it. So that is a learning strategy we are adopting. And for modeling, nothing changes. It's a simple .fit.predict. Yeah. And finally, we come up with our confusion matrix: accuracy, precision, recall, and F1 score, things that we've had before. And if this is new to you, don't worry. We are going to cover all this, and with time, it will be like at your fingertips. All right. Up to there, that was a quick recap of what we have covered. I know I was rapping, but I believe I did not lose anyone. I think I'm going to pause a bit and allow for any questions to be asked and any comments.
Ayub.
Yes?
Not on what we have been talking about, but just a concern. Are you going to share those slides in PDF format or something? The slides we have just used, or the code, I mean.
The Jupyter Notebook code?
Yeah.
Yes, I will. I will.
Oh.
I'm going to make them available. You can pull them from GitHub. So moving forward, all codes I won't be putting it on my website the way I used to do. I'll be putting them on GitHub, and you can download and access them.
Oh, okay.
Yeah. So I believe these are things that we had covered previously. Silas, I think you said that you did not attend last week's, the first session. Do you have any question?
Don't have a question. but I'm still driving. It's okay.
Oh, okay, okay. So this will be available. I was working with the slides. I was going through the slides. So I think at your own time you can combine the first recorded session and this one, and reach out if you have any question. All right. So if we look at the major steps in text classifications, there are two things for NLP. TF-IDF basically means term frequency inverse document frequency. So this is it's actually a mathematical formula that looks at the frequency within which certain terms appear on a document, as well as how, as compared to how the same term appears in a set of documents. So we will cover this, and it is a way of actually creating a sparse matrix. And there are techniques like word-to-vec, count vectorization. We will cover all those. And then the second NLP task is feature construction, which I've already mentioned. So basically, feature construction, we are building the sparse matrix and identifying the features within as per the features that we will use to build our model. Once we've constructed the features, we now we create the model using one of the available NLP or one of the available algorithms. It could be random forest, it could be naive Bayes, it could be logistic regression, it could be linear SVC. Some of these classification algorithms, we've mentioned them before, and this project will definitely let you know how we are going to apply them. After building a model, we do prediction, and after doing the prediction, we evaluate the performance of our model. By and large, these are the major steps of text classification. The only difference with other types of classification is step 1 and step 2, where we are in the process of building a sparse matrix. All right. So that is by and large the theory on NLP. I want to quickly show you guys the notebooks. Just give me a minute. I'm going to stop sharing this, and then I share the notebooks. Okay. Okay. Thank you, guys. I'm back. Please let me know if you can see my screen.
We can't see your screen.
You can't? Okay. Just give me a minute.
Naona mtu anakaa kwa Bahamas beach.
Kwa beach, eh? That's my life, man. That's my life. Nilifika huko. No jokes, my friend. No jokes. Lakini unajua, there's one thing with Zoom. Zoom hata unaweza kuwa America na uko tu hapa Kibira. So, it's the world you create, my friend. It's the world you create.
Sinderito ako Washington DC na kwa hapa Nyeri tu.
Kabisa, kabisa. It's the world you create. It's allowed. That's the beauty of Zoom. Okay, how about now? Can you see it?
Yes, we can. Okay.
So this is a set of notebooks explaining some of these concepts that I've covered in the slides. So tokenization, I'll just go through the code. Stop words, stemming, Ngram, lemmatization, and then binary text classification. And I'll also show, I'll walk through using the examples for using a data set that comes with scikit-learn. Yeah. So if we start with tokenization, nothing out of the norm. Like I mentioned during the slides, most of you guys you don't have notebooks, but I'll upload this and send the links for the recording together with the notebooks immediately I finish this class, so that to sequence your issue, I am sending documentation late. Yeah. So you take any text. This one I went to Google and extracted this text. And the first way of tokenizing is the common, for those who are doing programming, it is the common split. This split method is available in JavaScript. So you can split your text in using the word split. So when you split, it's actually splits it into several words. Now look at this. That is a word. Two, yeah. So that is a basic way of tokenizing when you echo the tokens, yeah. So that is one way. Don't worry, I'll just close this, but I'll definitely share. I'll share the notebook. Okay. Yes, Enrico, you have a question?
Yes, my question is via. You're going
Via.
to share via.
Okay, the recording is the normal way. The notebooks, I'll put them in GitHub. You can pull.
Okay, you'll share the link.
Yes, I will. Okay. All right. Tokens using, there's a library called NLTK. NLTK in full is Natural Language Toolkit. It's a Python library, and normally we have several libraries. There's one for Java. It's called, Stanford. Stanford also has a an NLP library toolkit. But for Python, this is what we'll be using, NLTK. So when you're tokenizing using an LTK, you need to import that library, and there's a method called word tokenizer. So you pass that text to that method, and you get your tokens. And then once you get your tokens, you can visualize them. It's not any different, but oops, I had closed one. Let me just open it again. I wanted to highlight something. If you look the difference between word tokenizer, check out that this word task, and then there was a comma, and the splits. So where is the word tasks? Check that out. You see? Can you see the difference?
Yeah.
Yeah. So with the split, the word task with the comma is treated as one token. Sorry. And then with the word tokenizer, each of them, it's a bit better. It's a bit better. Those are treated as two different tokens. So when you want to analyze or lemmatize this from to its root form, it becomes task, yeah, something like that. So if you want to process, you process. Okay. Now there's another one
Could you
called.
repeat that?
Sorry.
Could you repeat that?
Repeat lemmatization.
Yeah.
Okay, what I was saying is, unlike the split, which treats the word tasks together with a comma as a single token, when you're using word tokenizer, a library from NLTK, it actually looks at them as two tokens. So this one is advantageous, especially it is more refined. So you get absolute tokens as compared to the programming method for split. So if you want to move further to find the root word of tasks through lemmatization or even stemming, you see when you do lemma on this word task, you will get this word tasks, you'll get task. And when you do stemming for the same word, you will get task, depending on the method that you choose.
But before we do this word tokenization, don't we like remove is it stop words?
Yeah, the first step. Yeah, the first step is normally to create the tokens. After creating the tokens, you can remove the stop words, and then you refine those words to their root form, or even go further and lemmatize them. But the first step is just generating tokens.
Oh, I get it.
Yeah. Okay. So within the same library, there's one called Tweet Tokenizer. I really don't. I've never used it more in a real project, but my belief is in line with processing tweets. Yeah. So if you tokenize a certain text, for instance, I think I deleted that text. The text in full is hashtag NLP process can be made better using deep learning. Yeah. So when you tokenize that, you see the hashtag NLP process. It's something that is identified as a tweet, like it's a hashtag in a tweet. So if you want to do an analysis of hashtags, it is better to use tweet tokenizer than any other tokenizer. It's within the NLP library. And that is how you import it. So when you are processing tweets, then as a tokenizer, this is recommended. So if you want to, you'd want to treat at A4Ayub as a tweet handle as one token, as compared to if you use a normal tokenizer, which will remove the at part and separate it from A4Ayub. So that is the beauty of using a tweet tokenizer. Kwa pamoja? Enrico, you have something?
Yeah.
Okay, good. All right, now when we've already tokenized, we need to check out for stop words, words that really do not add value. So the English, there is an NLTK, the NLTK library, it has a package called WordNet. Rather, that package, it's like a bucket, it's like a corpus. A corpus is just a set of documents, yeah? It's called WordNet. And from this WordNet, you can actually identify English stop words, yeah? So stop words are, like I explained, words that do not really add meaning to a sentence and are completely irrelevant when you're doing your machine learning analysis, yeah? We use WordNet when we want to do lemmatization, so we need to add that, and then we import the stop words from the corpus. Yeah. Now to view all the English stop words, that is a command, and they are 179 in number. Excuse me. And you can actually see them in that corpus. Yeah. So if you want to do processing for your native language, you could just look for your grandfather, alafu umwambie jaribu uelewe what are the stop words in my native language. You come up with your own. So mtu akikoroga Kisapere ama Kijaluo, you remove the stop words from it. Yeah. So in English, this is how it is, and these are the words that we're going to remove. And another thing that we're going to remove during data cleaning is the punctuation. The punctuation needs to be removed completely before being passed to the machine learning algorithm. Any question up to there? Yeah.
Okay, I have a question.
Yes. Yes.
Up to this point, sorry, bado. Okay, now bado hatuja vectorize.
Bado.
So my question was, can you perform vitu ka name entity recognition and POS kwa a vectorized matrix? Ama
No.
ikishaende sasa tu ni kwenda straight.
Yes, after vectorization, after using count vectorizer, you've already created the sparse matrix. After that, you just go to building your model. So there is a library used called Spacey that helps you with entity extractions. So you might want to create a model that is just good in extracting entities, and then you pass, let me say, for instance, the first classifier that you build a classifier that determines the intention, you get? And that is what you were calling earlier on intent classifier. So once you build a classifier that actually helps you extract intention, so you go to Facebook, extract a lot of conversation, and then you want to see which conversations out of all these millions conversation is about real estate. So most probably you want to channel all those conversations for real estate into a specific workflow. So once you have identified, okay, this text is about real estate, and that real estate would be, you want to extract only conversation about Langata, for instance. Yeah. So you would want to build a model using Spacey that actually would be able to extract estate names. You get? The same way you train a model to know the intents, you can actually generate one using either Spacy or the available techniques that is just good in extracting estate names. So once you have this model, you say this is conversation for real estate. Does it have estate names? So if it has estate names, iskume tu mpaka finally you determine that either that conversation is about someone who was looking for a 3-bedroom house in Langata and their budget was 30,000 Kenyan shillings. You get? So you've been able to extract the amount, you've been able to extract the estate, you've been able to extract any other important information in that conversation. So entity extraction is actually a process, but the moment you build a sparse matrix, either after the count vectorizer, then you cannot do entity extraction after vectorizing your text because the vector is just ones and zeros.
Asante.
Kupoa? Unajua mimi usiponiweka break nitaendelea na niendelee. Umeelewa lakini?
Nimeelewa, asante.
Sawa. Okay. Now, yeah, stopwords. Now, this is how you remove the stopwords. Yeah. And then the next one I want to show is stemming. We have several stemming techniques. And again, all these are derived from NLTK. They're equivalent when you're using Stanford library. But like I said, our conversation is with regards to NLTK. One I'm going to use here is called Porter's Stemma. Yeah. So you initialize you import the library, and then you instantiate, you create an object here. For those people who have done programming, you understand. This is just a way of creating an instance of this so that you can start using this one. So once you've created an instance, and now you want to call methods within this instance, the first method is to stem. So you're giving it a text and telling it to stem it. Now when it stems it, you see now the root word here is learn. Yeah. So learned, the root word according to Porter's stemma is learned. So when you look at this, learned, it is still learn. Fish, it is fish. Fishing is fish. Fisher is fisher. Fished is fish. Fishers is fish. So there are some stemmas that are more radical. There are stemmas that are a bit lenient. So you could play around. This is now something you would want to test several stemmas, yeah, in your that are available in NLTK. So to check the available stemmas, there is a site NLTK. I think nltk.org. It's an open library. Yes, nltk.org. Let's open it, and you could check. Go to the wiki. We have, this is Stanford Core NLP. Stemma. Oh, well, better yet, let's just say NLTK stemma. System of comparison. Open stemmas in NLTK. When you look at this, we have Porter's stemma, we have Snowball stemma. Yeah, Porter's stemma and Snowball stemma. So you could play around and check out which of these is better. For instance, if we do Snowball stemma and come back to our stemming Jupyter notebook, let's run these notebooks. Import NLTK, and then we import Snowball. Just check it out. There, it has run Snowball stemma. We've imported that. So there is this part, the results for which one? Like this one, for instance. If we do this, we instantiate it, then we run it, learn, And then snowball stemmer is equals to snowball stemmer. Snowball stemmer, SP stemmer. Language, there is a parameter that needs to be passed. English. Okay. So if we were to use the same, what will it tell us? If we were to use the same, learn, it is the same. Kuna moja hapa, let's see, kuna ile yenye ilisema learned. It's still learned. So it's not as radical. Let's see, let's try again this one. For Fisher. Learn. Snowball stemmer. Nimekopi gani? Ni hapa. Fisher. It's still Fisher. Anyway, you can check. There are some instances where you'll find one to be so radical. You can play around with them in your analysis, but there are several that have been available. So that is the essence of a stemmer. And then we have Ngram, what I was talking about. If you choose, for instance, this one we've already imported. We import the NLTK library. And then we want to check this counter is to help us check combination of words and their frequency within documents. So if you have a document and you decide to split it into groups containing 2 words each, meaning it's a bigram, or groups containing 3 words each, how often, what is the frequency of the presence of that combination in the documents? Yeah, so that is what you use the counter for. So for instance, we've imported that, and there, counter, and then we take that text, for instance, and then we do a counter for each of the words. But now here it's a bigram we are extracting. So if we do that on that sentence, you see, it's appearing artificial and intelligence. It's appearing. This combination is appearing once. Intelligence and is appearing once. So you can do that analysis, and you can also try with 3 or 4, so bigrams or 4grams. So those are some of the things that would help you determine what is going to help in getting the intention of the customer much better. So that is what it can even help you. What is the presence of which combination of words contribute more to the meaning or the intention of a customer? Intent classification. That is the question you had asked. So this is one of the techniques that can actually help you come up with better classifiers for NLPs. Yeah, so this one is for, like I said, trigrams. So it looks at 3 combinations: artificial, intelligence, and is. The next one is said intelligence is based. So there are several. This text might not be a good example, but the concept is well explained for Ngrams. But the moment you start working with a lot of text, and that's why I was proposing that for this class, we engage someone who's done crawling, like scrapping data, especially in Facebook, for looking for specific conversation. So we will get raw data. Tutapambana nayo kabisa. Haitakuwa kitu yenye nime-experience, haitakuwa kitu yenye nyinyi mme-experience. Kwa hiyo tunapambana nayo kwa class. That will be the best. So at the end of this class, I'm going to make that request, and nitarusha kitu. Nitarusha kitu kwa mwenye atafanya hiyo kazi. So Please remind me immediately we finish this class. So that is Ngram extraction, yeah? And then we do lemmatization, yeah? Just like stemming, we have lemmas. So the one you're going to use is WordNet lemmatizer. So you instantiate them, and then you use them more or less the same way, yeah? Dot lemmatize, dot lemmatize, dot lemmatize. When it's stemming, dot stem, dot stem, dot stem. Okay, all right. This one is close to a classifier. It's a bit longer, um, uh, depending on the library that is available on scikit-learn. Yeah. So you use WordNet. The library, or rather the corpus, is called Reuters. So Reuters is a conversation of the Reuters who normally publish news dataset. So it is available on NLTK, yeah. And then we will actually see how we use TF-IDF, the term frequency inverse document frequency vectorizer. So this is what would help us build our sparse matrix. And then we will use pre-processing techniques, multi-class, probably not in this notebook, but in the next class, we'll actually see and experience all this, yeah? So the first thing is an example of how to remove stopwords, to import stopwords in your notebook. When you're tokenizing, this I think we've gone through it, yeah? So this is an example of text classification problem. So the objective here, the viewer had asked the question. The objective here is to determine which conversations are about sports, yeah? So you look at these sentences and you derive manually. This is just a manual process, a very simple manual process of creating and splitting data sets, yeah? So you create your data, train labels. We have sports based on the first sentence. This sentence here, up to here, it's about sports. The referee has been bad this season. It's also about sports. Our team scored 5 goals. That is still sports. I love tennis. That is still sports. And politics is in the increase in Kenya. That is not sports. So basically, these conversations, based on what something has said, you have labels accordingly. These labels are like now the Y variable, which is the target variable. So you can sprint the labels. Ideally, some of these conversations are normally made present in Excel sheet, in straightforward. One column has the conversation, and then the next column has the label, yeah? So that was for the trained data set, and then for the test data set, the same way, the same thing. So that we will do this and then test it using this test data set. This one is just to illustrate manually in a very, very simple language how we are going to approach solving some of these problems, especially when you're building a retrieval-based chatbot using classifiers, yeah? So the test levels are as been displayed. Now here is where we instantiate our vectorizer, the one that would help us create the sparse matrix, yeah? And then basically the vectorized train data as well as the test data, yeah? This is the vectorizer itself, object, but now these are the hyperparameters that the object uses. With time, you'll get to know and understand what all of this stuff are. Between now and the next class, nothing is preventing you from doing more in-depth analysis of each of these words. And then we engage in class to help each other, like now to firmly understand what each of these words or each of these hyperparameters mean, or any of these things that we've covered so far, okay? All right, now the train data. So this one just means this is the document. Document is like now for example, this one constitutes a document. This one constitutes a document. This one constitutes a document. So it's like one reference, one verbatim that has been mentioned in the conversation. So if you look at this vectorized train data, it tells you that the TF-IDF value, because these are now the TF-IDF value, the term term frequency, invert document frequency that we have generated using this technique. So when you print this, it's telling you on the first document, the word number 5, the word at index 5, sorry, the word at index 5 has this value. So you look at this TF-IDF values, and the importance of that TF-IDF value is as a result of there are instances when you have word like cat and cats. So a cat and the cats, if both of them might be the same, but they have different TF-IDF values, and the significance of that would be very, very clear on the outcome of your prediction. I know Chris, there's something we've worked with and we've tested on the classifiers. When we add either a word or a string, it gives different responses. So the next iteration would be, can we get specific values of the TF-IDF values of those words and try and put an index to it. So there are several, the beauty of machine learning is come up with a base classifier, or come up with a base problem, and then based on what you're observing, iterate. That is the best way to learn. So this is how you actually get to know TF-IDF values for words in any document. So this one means it's the 4th document, or rather the 5th, because indexes are from 0. The 5th document and the word number 9. The word at index 9 has this, okay? Right. So to start modeling, once we have our sparse matrix, we instantiate the classifier. Now we are going to build a linear SVC. It's a good one. You can use it for it's actually a classifier. You can use it for classification. And then you fit the sparse matrix and map them with the training labels. Once you fit, and then you can do your predictions. So since it's just a simple data set, there is overfitting. You get, yeah, because it's just too good in knowing and understanding the data. Yeah, I've explained this. Common issues. It's when, for example, you have car and cars. It has different values, and the illustration below here is mapping the word with its the extracted feature and extracted TF-IDF value. Yeah, so the threshold defined can be used to make some decisions in your workflow. Okay, it's starting to get interesting, and the interesting bit is the moment we start building the sparse matrix. So it is a very, very key focus area, and the difference with normal classification problems where we are not handling text is clearer now. Yeah, and yeah, you can do the test data and do your prediction as well. I think that is a bit more detailed notebook than the previous ones, where we are just looking at the concept. This one we are moving towards doing predictions, and eventually we will have to see the classification metrics, yeah, the classification reports and confusion metrics. Okay. Now using the Reuters data, it's more or less the same thing. So the Reuters data is the way it's split. You have test data and you have the trained data, and you have document IDs. Like what you're seeing there is document IDs. So if you want to print, we have 10,788 documents. Then this one is just to separate this data into train and test. So a simpler way is you're checking in that document that starts with train, yeah, from the docs. So the docs is this, and you're filtering whatever you're looping through and checking for each doc that starts with train, put it in train's docs ID. That is what this is. So you're listing them, and you're doing accounts. You're doing accounts, and you get that it is 7,769. You do the same thing for test doc that starts with this. It is 3,019. If you want to analyze a specific document with this document ID, this is how you get it. So you want to view the raw verbatim, this is how you check the word, the specific word. And now from here, you can actually write Python programs or Python scripts to start analyzing not only one document, but the entire set of documents. For instance, the beauty of the relators tag, this is an example of a multi-label problem where the output could be one of many, unlike a binary problem where the output could be one of two. This one is multi-label, so conversation could be either for barley, corn, grain, or wheat. Yeah, so this document has been categorized, and based on the output, it's the topics, rather not, because we are not predicting the topics of this text. It could fall in one of any of these. It could be barley, corn, grain, wheat. Yeah, because of looking at what the values are here. Okay. All right. Now this is the process where we want to see the categories. The categories that are in that document. Yes. And the count of categories in the entire document set is 90. And when you list them, these are the ones. So we could actually build if you don't have, for instance, if you don't have a ready text sample data to start your NLP, and your NLP you want conversation about livestock, for instance, you could start with this because there is labeled data and you have some text in this that can classify some text on livestock. So as you build your conversation, you increase. As you get your data, you increase, and then within a very short time, you'll have enough data set, and you'll now abandon using the Reuters data set, and you start using your data set. Like right now, we are planning to build a chatbot for real estate. We could start with this and mine data from Facebook, label that data, map it with this, or we could start with this one and enable people to play around with it as we extract housing and estate. When we get quite a number of conversations, we now will redo the chatbot classifiers using the dataset that we collected. So this one are all the categories. We can put them as the Y target variables and be able to predict this conversation is about livestock? Is it about housing? Is it about income? Yeah, we can determine that depending on the problem statement that you want to solve in your independent NLP project, because you'll have independent NLP project, or you'll team up with one person, maximum 2 other people. So you're in 3 people, you build your independent NLP project, and we see that it is taken to production. So the one we are going to use in class, we will not use it to take it to production. It is what you will think of and implement what you've learned. That is what we will take to production. What we do in class, I think I'll be the one to take it in production, and you guys can actually see and learn from it. So if you want to implement a certain technique, we consult and you do your project all the way. That way you can actually articulate how you approached and solved that problem to anyone who cares to know how you did it, all right? So the other methods, this is just a list that actually help us identify how many documents are there in each of the categories. And you can actually list the top 10. This is what gives you a list of the top 10. So top 10, I don't know what this ACQ is. Maybe it's an acronym for acquisition. This is aluminum, this is barley, there is carcass, castor oil, 10,000. So it's look like it's balanced based on each category has approximately the same kind of data records. So people talking about coffee, we have 10,000, approximately 10,788 observations, yeah? And you could print the entire category list, yeah? And that's it, man. That's it with the Reuters. I've really wrapped because I know this time is normally precious for those with family and those who have had the long days. So I think that'll be it for today. The next class is going to be more interesting. And I'm going to open now this floor for questions. Unless I was talking by myself.
When is the next class?
Next week, Wednesday. We'll be having NLP every Wednesday.
Okay, thanks.
Same time. Same time. Yes,
Just
Enrico?
to ask, I like this, but also was wondering
Uh-huh.
if it's possible to like always be having like the notebooks early in advance, because I'm having a lot of trouble squinting on my screen.
Okay. Okay. All right. You say how many days before? Is it a day or 2 days?
Well, even the same day before the class itself. It doesn't
All right. Okay. So
like,
we can work with
so that when you're going through it, I'm also going through it
going
on
through
my
it.
side.
All right. Okay. I think that can happen. What we can work with is let's do it a day, at least a day before. Meaning, if the class is on Wednesday, you get the notebook on Monday.
Okay.
Yeah, Monday end of day. So I could
Daudi can be reminding you.
Yes, I don't mind, please. I know I need someone to put me on pressure. I can really disappear in my own world, and nikipata pressure from you guys, I'll be on toes. So I'll definitely appreciate that kind of pressure.
Daudi, take up the mantle.
Daudi sasa
I
ndio
need,
huyo yes, Silas.
Daudi and me.
Yes, I know Silas also has been putting me on pressure. Oh my goodness. Mimi niko motoni. Kwanza Silas. But I accept that. Silas and Daudi, you guys have been appointed as the rep for this class, the class rep.
I hope they don't write noisemakers.
Yeah, the noisemakers.
Tunajua Daudi.
Okay. So Silas, I think I'll take up that challenge. I don't mind you putting pressure on me for you guys to have the notebook.
Sasa wananiita noisemaker.
Hapana, wewe ndio inafaa muongeze kwanza kwa hiyo list ya noisemakers. Huyo Enrico muongeze kwa hiyo, inafaa muongeze. Okay, so I think I like that proposal. I have no problem. So I'll commit to making this available by Monday. Monday at least by 6 p.m. Itakuwa mnakuwa na notebooks.
Awesome.
Okay.
That's really better.
Yeah. So that is fine. So at least this class has. Yes.
Nimeingia kwa nyumba. Let me sign off.
Okay, so no problem. I think there's no much unless there's other question. There's someone else who wanted to say something.
Ni mimi.
Yes, go ahead.
Nimeona it's like a couple of notebooks. So you provide in a way tunaweza track which notebook is which, ndio ikuwe much easier to follow when I need to read.
Okay.
If it is possible.
Yes, it is possible. What I'll do in the GitHub, I'll put them based on the class sessions as well as the topics. So they'll be a bit organized.
Okay.
So it will be available.
Okay.
Alafu, Edgar, you had something?
Actually, it has been echoed out. I want to talk about vile Eric amesema, like we have the mapema, we have the notebooks earlier so that at least by the time you have a class, we are at par. At least you will be explaining what you didn't understand, what one we did not understand.
Okay, all right.
Yeah.
That's fine. I'm going to make them available in that format.
But so far, actually, at least this one was better than at least, I don't know, last time you were so green. This one, at least you understood some parts of it, even though I was trying to multitask, but I got it right.
Okay,
Yeah.
I know with time it will get better.
Yeah.
So even if you don't understand a concept now, don't worry. Just be consistent in the sessions. There will be something that you'll pick. There'll be something that you'll pick.
Sure.
Any other question?
Mimi niko sawa.
Okay. Deno? Uko sawa? Kuna jamaa anaitwa Christopher. Christopher umetulia kabisa. Hebu fungua roho.
Niko sawa. Mimi ndio niko hapo kwa Edgar ya last time Yeah, but I will revisit. Leo wenyewe tu sijui ni kuchoka, nimefanya kazi mingi, nimeupload
think-
tu but
Yes, I think.
I'll push.
Don't worry. What I can recommend is, I know evening classes is a bit tiring because watu wenye wanafanya job mchana wamechoka, so we can't go beyond 2 hours. What I'll encourage you guys to play and follow through the audio which I'm going to upload, and then with the availability of the notebooks, you can actually go through them. At least whatever question you have today, kama ulikuwa na swali, like for example you have 3 things that are not clear today, by next week Wednesday at least tujue moja, so that ubebe mbili tu pekee, alafu hizo mbili uniulize nijibu kwa hiyo class. Pole pole tu tutafika huko. Hakuna haraka. Labda sasa Jesus decides to come back tomorrow, that's when you say okay, we are going home.
Will you be there?
Yes,
I'm not judging. I'm not judging.
Okay. So is there any other person?
Are we starting another discussion of one of us here?
Inaishia hapo Chris. Inaishia hapo. Sawa basi. Miano, I saw you joined a bit later. Are you okay? Do you need something?
Yeah, I'm just wondering, like you never get errors while running your code. How do you do it?
I do. There were some errors even on the screen, but the errors is like a constant in a developer's life. Those ones lazima utapata. Without errors you will never learn. So lazima utapata.
Zitakutandika kwa sababu zinapatana ukiwa kwa client zinaanza kucheza dogolo.
Yes. Okay. Timo, do you have anything?
I was just asking.
Yes.
This class project, this chat box we are creating. You said it's about real estate tracking.
Not real estate tracking. I know we'll be releasing information as we progress, depending on the context. But now, to just put a picture, the problem is, or rather, I introduced it in the previous meeting. The perceived problem, because we'll need to articulate that it's actually a problem. The perceived problem is finding houses is difficult.
Yeah.
Can we build a chatbot that makes it easier? It gives us answers and it probably tells us which houses are available based on conversations that are ongoing on social media.
Oh.
Yeah. So if someone is looking for a house, yes?
Alafu hiyo sasa hiyo model, can it be made like reusable, like for example like mse wa e-commerce anaweza use it to tell the consumers which products akonazo wanaweza buy? Because I guess it will be the same way. Mtu akiulizia kuhusu nyumba anapatia the same specifications would definitely work for a commerce store pia.
Absolutely.
That's kind of free.
Absolutely. So actually, Devi, you've actually put it in very, very good words. So you see, the learning path you're going to follow is for real estate. Yeah. But now the individual project is for you guys to identify unique areas within which you can apply what you've learned. So e-commerce, can you build a chatbot that is very good in helping someone to shop or answering questions about a specific supermarket, for instance? So we start from generating that data, and then we go to cleaning that data, creating a sparse matrix, building a model, getting results, and then plugging it into production. So that would be the scope of your individual project. And an individual project could be either one person or a maximum of 3 people. If you're working in a team, the better, because there are things that you will learn that you will never learn when you're working by yourselves. So handling more than 2 people in a team would really, really help you in a big, big way. So if you're looking for a project, identify 2 people, and then you work and see this project to production. So you've gotten it right. Leave you, it's possible. Okay. Who else has not spoken? I think everyone has given feedback. Is there any other question?
Iko sawa.
Uko poa?
Sawa.
Good stuff. So I think this marks the end of the session. I really hope it was worthwhile. And
Yeah, sure.
moving
Sure,
forward.
Okay,
other-
Robert, before you
yes?
leave,
Uh-huh.
I'm asking this chatbot.
Sorry?
I'm asking,
Uh-huh.
yeah, this chat that we will create.
Mm-hmm.
Will it be running on the ones that I see on Telegram or Facebook or independent?
We will take it to wherever we want to take it. For example, if you come up with a chatbot that is good in shopping, yeah, and you want it to, the first place we are going to integrate is the platform called Chatify. Once we integrate it with Chatbot, with Chatify, if you want it to be plugged into Facebook, I will actually work and make sure that it's available on Facebook. Yeah. So when you have a Facebook, if you want to talk to someone on Facebook, they can find it on Facebook. So all those integration is possible. And when we are integrating, we'll be learning. Yes.
Just suggestion.
Okay.
Yes.
To see, we can just create endpoints for the chatbot so that you can be able to extend it to wherever you want
Absolutely.
it.
Exactly.
Facebook. So
yes.
it will just be an API and itakuwa na endpoints and you can
Kabisa.
contact.
Exactly. 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 So Miano, I think what Miano might have meant is okay. If you're a developer, then you know how to develop in Facebook. Since we have an endpoint, you just develop. What is it called? The Facebook client, and you use the endpoint that we have come up with, and you experience the chatbot.
Okay, fine.
Yeah. Okay. So until next week, I think we are good. And just to take note is all I need for a class to start is 3 people, even 1 person. I was about to start ndio nikasema okay, wacha tungoje wengine. So because of the time, I think I'll be starting. I'll only give a window of 15 minutes, and then even if it's 1 person, I will start the class.
That's 6:15.
The good thing is the audio is recorded. You won't miss anything. What you will miss is to participate in class, and it helps.
Very good.
All right.
To send the links.
Okay, I will. Okay, guys. Sorry, and Nini, sorry. I had mentioned about scrapping data from Facebook. I think Devi or any other person who is able to do it, please let's engage. Let me know, because I would want us to build a scrapper that we can use to get the data that we will use, especially for starting. So we can have this discussion offline.
Cool.
All right. See you guys. Thank you very much. See you again next time.
Bye, Robert.
Bye.
See you guys.